Yeah.
Okay, so let's start. Hello and welcome. My name is Milos Pujic. I'm a test architect and department manager in NINEAIR Novi Sad office. And today I will present to you our do-it-yourself solution for air quality sensor, which is the integral part of our Hack9 upcoming event. So let's start. Some of you have already noticed that across our offices, that on the balconies, windows, and outer walls, there are some little blue boxes with Levi 9 branding and something like NINEAIR writings on them. Those are basically our finished sensors deployed across our locations, which are already gathering air quality data and it's sending to the cloud. And today we will start this year Hack9 introduction by presenting what's inside those boxes and how you can build them yourself, if you want to. Okay, so on the left side, you basically can see what's inside. And what was our idea behind this NINEAIR sensor, that we have our own air quality sensor that will gather data outside of our offices so that we don't rely that much on the government and community sensors, which might not be like physically nearby. That our sensor is easy to build yourself and that you can measure particulate matter concentration as well as temperature, humidity, and pressure. That only uses easily accessible and affordable off-the-shelf components. All the components in NINEAIR, except custom 3D printed case, can be easily found and bought in local electronics store on websites like eBay, AliExpress, Banggood, or similar. And also it was important that it can be built and operated in a home environment so that you don't need like any kind of professional tools or some kind of network equipment to operate it. And the only tools that you need is some soldering iron and little soldering skills, as only one of the sensors requires some little bit of soldering. Everything else is just proper wiring. Yeah, we will talk about everything you see on the picture except the 3D printed case, which is custom 3D printed for the Hack9 event. And more about that, our colleague Stefan will talk about on next Hack9 presentation. So what you need to build it? You need Raspberry Pi. In our case, we use Raspberry Pi 3 model A+. You will need a power supply, which is powerful enough to power everything, Raspberry Pi and sensors. You will need an SD card because Raspberry Pi does not have its own internal storage and you need somewhere to put the operating system and the application that you develop. You will need a PMS 7003 sensor, which is particulate matter sensor. Basically the main one which measures air quality. You will need a BMP 280 sensor, which is a barometric pressure sensor. DHTI 11, which is a temperature and humidity sensor, and of course some jump wires to connect the sensors with the Raspberry Pi. Now we will go into the detail of each of the components that we have. So we have, as I said, the Raspberry Pi, which is like main compute unit of our air quality sensor. More exactly, we use a Raspberry Pi 3 model A+. Its size, interfaces, and CPU power was enough for our needs. It has a 64-bit quad-core CPU at 1.4 gigahertz, dual band Wi-Fi with Bluetooth, and extended 40-pin GPIO header to connect the sensors. Currently on the market, you can also buy a Raspberry Pi 4 Model B, which is quite more powerful than this one. It has more CPU power, more input-output ports, including the Ethernet port. However, we didn't go with it as it is larger in size. It has more input-output ports, which didn't make any difference for us as we don't need them. Ethernet port is a good addition, but that means that we would need to have like additional cable to connected to our sensor. Power over Ethernet was also an option because it does support it, but only with additional like PCB board attached to the Raspberry Pi. It's called PoE hat. And in the end, that Raspberry Pi sensor is maybe not much more, but more power hungry than the version 3. So of course, if you want to build this sensor, but you also want to tinker around with different kind of variety of projects and have more options, I suggest that you go with the Raspberry Pi 4. But if you want just to build this air quality sensor, Raspberry Pi 3 in model A+ variant will be enough. Also, as I said, we will need a SD card for the storage. but it should be 8 gigs or more to feed the OS and the applications. For the OS, we went with the Raspberry Pi OS, which is a Linux Debian port, and we went with the desktop version because it has all dependencies pre-installed. Later on, we just disable the desktop environment after installation. And of course, you will need a power supply for the Raspberry 3 Model A Plus. 5 volt DC with 2.5 amps is enough to power on the Raspberry Pi together with all the sensors. It uses standard micro USB connector like the older smartphones. So this is basically how Raspberry Pi pinout looks like, and this is how it's oriented for the Raspberry Pi 3A Plus. I'm showing this picture here as a reference because on the later slides, when showing how to connect each sensor, I will be just using the pinout picture because on pinout picture you can see the numbers of the physical ports. So in the circle box, in circles and I think only one box, these are the pin numbers, physical pin numbers, and next to them you can basically see the purpose of each pin. I will use for easier communication, I will use the physical pin numbers when describing what to connect with what. Or if you want to gain more knowledge about the pins and everything, you can visit this great site called Pinout XYZ, and on it you will see basically this description for all the pins you have on the Raspberry Pi. Important to note here is that most of the Raspberry Pis have the same pinout, or every new version has maybe some slight modification, but each new version is backward compatible with the previous one. So let's start with our sensors. First sensor which we have is PMS 7003, which is a digital universal particle concentration sensor, which is using high precision laser to obtain the number of suspended particles in the air. Basically, it measures the concentration of particles in the air and outputs them in a digital form as the number of each particle with different size per unit volume. It can measure PM1, PM2.5, PM10 particles. For this sensor, you don't need any soldering. And for communication with the Raspberry Pi, it uses a dedicated adapter, which maps 10 pins from the sensor to the 4 pins needed for the serial communication with the Raspberry Pi. The communication goes over UART protocol, and for it we have exposed from the sensor ports pins like TX, which is transport, RX, which is receive, VCC port, which is positive power and it uses 5 volt power pin, and of course ground. How to connect it to the Raspberry Pi? First, I will go into the detail how you need to enable these things on the Raspberry Pi, but first you need to enable serial port on the Raspberry Pi because by default in the Raspberry Pi OS it comes disabled. But you also need to keep the serial console shell disabled because if we enable that, it won't be possible to communication between the Raspberry Pi and PMS sensor won't be possible. And how to connect it? Basically on this pinout diagram, you can see that we connect sensor RX pin to the Raspberry Pi physical pin 8, which is actually TX pin on the Raspberry Pi. So RX pin from the sensor go to the TX pin on the Raspberry Pi. Same for the TX pin from the sensor, it goes to the pin 10, which is RX pin on the Raspberry Pi. VCC pin, like a positive power, goes to the Raspberry Pi pin 4, that's a 5 volt pin, and ground pin goes to the pin 6, which is a ground pin on the Raspberry Pi. Also, good to note here is that VCC, like power and ground, can be connected to any other pins on the Raspberry Pi, which provides 5 volts and ground. But we choose these two 5 volts and ground because they're close to the TX and RX pin on the Raspberry Pi. Okay, our next sensor is BMP280. That's a high precision and low power digital barometric pressure sensor, which is using piezoresistive pressure sensor technology with high accuracy, and as well it has a really long-term stability and high robustness. It basically measures atmospheric pressure and temperature, but because pressure changes with altitude and pressure measurements are so good on this sensor, it can also be used as an altimeter and measure the altitude based on the pressure. This is the one sensor which requires a little bit of soldering, because it usually comes like this PCB board and separated with a header strip. And this header strip must be soldered to the PCB board. There are 6 pins that need to be soldered. And out of those 6 pins, we will use only 4 pins for communication with the Raspberry Pi. It will communicate over E2C protocol, E2C bus, which is, I think, abbreviation of integrated circuit bus. And those 4 pins which we'll use are SCL pins. They're also marked here on the board. You can see if you tinker with it, all of them will be marked on the board. So SCL pin, which is serial clock pin, SDA pin, serial data pin. Also, we have VCC pin for positive power, but this sensor uses 3.3 volt, not 5 volts like PMS. And we have a ground sensor, a ground pin, sorry. And how you will connect them to the Raspberry Pi. First, you need to enable I2C interface, because as the serial one, it comes disabled outside when you install the Raspberry Pi OS. After you enable it, you just connect the pins as marked here. So sensor SCL pin go to the Raspberry Pi pin 5, which is SCL pin on the Raspberry. SDA pin go to the pin 3, which is SDA pin. VCC power pin goes to the pin 1, which is a 3.3 volt power pin. And ground pin goes to the pin 9, which is ground pin on the Raspberry. Same as for the other sensor. VCC and ground can go to other VCC and ground pins, but you need to honor that it must be like 3.33 volts. Yeah, we choose this one as they're close by to the SDA and SCL pins. And the last sensor that we have in our air quality station is DHT11. This is a ultra low cost digital temperature and humidity sensor, which uses capacitive humidity sensor thermistor to measure surrounding air, and outputs it is a digital signal on the data pin. As it is an ultra low cost sensor, we had I would say problematic quality and precisions with this one. At the end, we had to buy like double the number than we needed as a replacement, because during testing we found out that even in indoor environment, when we have all of them connected and lie down on the table next to each other, they were not showing the same numbers. We tried with recalibration of them, like there were like this description of the internet, you need to like froze them and or cook them, but yeah, that didn't work. Then we used the buy the replacement ones and tried to have as close number as possible. However, when we pack them and expose them to the external environments, outside environments, again they were having like a big difference in the results. And because of this, I would suggest that during hackathon you don't take that much into consideration, especially temperature values from this sensor. Yeah, I think the humidity would be is okay. This one usually does not require any soldering, because it comes soldered to the PCB like shown in the picture. In some variation, this blue part, which is actual sensor, can be sold separately, and you need to solder them as the previous sensor. But as we saw, on most shops available on the internet, it comes like this soldered to the board. It uses single data pin for communication, and of course, besides that, it has that's a single pin, and besides that, it also has a VCC for the positive power supply. It also uses 3.3 volts power, and it has a ground pin. For finding out which pin is which, on the board you will see like markings S. That one is marking the data pin, and marking minus usually marks usually always mark the ground. There's some variation where you will have like plus and minus. That means that the pin next to the plus sign will be this power port, and then the one leftover port will be the one without markings, and that in this case that will be single port. Yeah, again, you can connect VCC and ground. Okay, sorry, I need to first go to the next slide. Come on, So how to connect it? Yeah, for this one, you don't need to enable anything in the Raspberry Pi because it uses only one GPIO IO pin to communicate, and you just connect it like connecting the signal data pin to the Raspberry. We choose pin 15. And you need to connect the VCC pin to pin 17, which is also 3.3 volt pin, and ground pin like we connect it to the pin 14. But yeah, you can connect it to any other 3.3 volt and any other ground pin. This is just like for our convenience because it was close enough to the data port. And how it looks like when everything is connected is basically like this. You have like three sensors which are connected to the Raspberry Pi, and this is when how it looks like when all these pinouts are connected to it. And now, if you would like try to just power it on, nothing will happen because there is no operating system on Raspberry Pi. There is no any software which will run the sensors. And how you can make it work? Basically, you need to install the operating system on the Raspberry Pi. You will need a SD card reader for your SD card, and you need to download a Raspberry Pi imager tool from the official Raspberry Pi website. With this tool, you just go to the installation guides where it is shown in this short recording where you select the operating system, select the SD card that you want to use, and also optionally you can pre-configure your operating system. I said optionally, and I will say it later why. With this optional configuration, you can set immediately its own host name. You can enable SSH connection on the Raspberry Pi. But you need to set also the username and password of the system user. You can configure the Wi-Fi network on which Raspberry Pi will be connected on the initial boot, and you can configure the localization settings like time zone and keyboard. And basically, you can skip this if you plan to start doing the initial boot of your Raspberry with all peripherals connected, like connected monitor, connected mouse, connected keyboard, because this will be asked on the first system boot. But if you just want to plug it into the power outlet, and yeah, everything should be like just started, you can use the initial pre-configuration of the system, and then you can just SSH to your Raspberry Pi and continue your work. You don't need to connect any peripheral like keyboard, monitor to it to configure it. And when we have our operating system running, as I said before, you need to enable some interfaces for our sensors to work. For the PMS 703, as I said, you need to enable a serial port on the Raspberry Pi, but keep the disable the serial console shell. And for the BMP 280, you need to enable the E2C bus interface on the Raspberry. It can be done via UI, like if you connect the monitor to it, it will boot in with the desktop on, or you can use the VNC connection. And by using the UI, you can just click on the home button, go to Preference, Raspberry Pi configuration. Under Interfaces tab, you will see the interfaces you can enable, and make sure that E2C serial port are enabled and serial console is disabled. After that, you click on OK button, and it will require the reboot of the Raspberry so that it is applied. But if you are going to use SSH and terminal, you can use the tool called Raspi config, and you will see, I think now it will start again. You can open that tool, and with it in terminal, you can also do the same thing, but yeah, using the navigation with arrows, you can go and enable serial port without the serial console, and you can enable E2C also from the terminal. You don't need to like use UI, and after that you will also need to restart the Raspberry Pi to be applied. And after we have all of that connected and enabled, you can test your own sensors. For it, you have like abundance on internet in different languages, scripts and libraries which you can use. We choose, which was easy for us to use Python. There are already a couple of libraries which can be used and which provide great solution. And we just need to write some small script which employ those libraries and get the values from the sensor. This is our script where we use the libraries. We just need to like say which sensor or uses which interface, and for DHT, which port is used for connection. After that, We just get the data, and yeah, this all is like printing out the results. Don't worry, we have this test script and everything available on the GitHub repository. You can see the link below, and also it is behind this QR code. And when you have this script, you can just run it, and it will start printing out the numbers from the sensors in the time interval that you define in the script. And yeah, basically that's how you make your sensors work, and you get the readings from them. The cloud part and everything else will be shown on our next presentation. The next presentation is actually, I think, tomorrow. Presenter is our colleague Stefan Bolesnikov, which will show you how to create a 3D casing, which we use for this Raspberry Pi. And yeah, the days following on May 12, you will see how to gather all this data and display it in the cloud. Afterwards, you will see the AWS solution and Azure solution. So that's basically all that I had to share with you, and you can start asking questions if you have some regarding the sensor and possibly Hack9 event.
Can I be the first with the
Sure.
question?
Sure, Sergey.
Yeah. What was the reason to use DHT11 instead of upgrading BMP 280 to BME 280?
Yeah,
you expected that question, yeah?
Yeah, of course. We also, yeah, when we saw the precision of DHT11, because yeah, we really didn't know about, because its quality and it varies a lot. We saw that there is also DHT22, which offer more precision, but yeah, later on we also see that we can use another BMP sensor. But yeah, this is, I would say, our first version. Of course, for the temperature, it's not only sensors. It also matters, especially for the temperature, the positioning, the shade, the exposure to the sun. Yeah, we also would be need to like upgrade our casing a little bit for the temperature to be correct. But yeah, there are more precise sensors than this one for the temperature, and I guess a newer version for the BMP of two, of course.
And
yeah, maybe
yeah, go ahead.
Yeah, just to jump into add something. Yeah, BME is let's say better. But yeah, since we were buying those sensors in Serbia, it's like a shortage of them, and they're much more expensive than the ones we used. But also, yeah, we wanted to experiment a bit and learn what we learned. So also Hack a bit while preparing for Hack9. So in the end, it was not the goal was not only to create the perfect device that is measuring everything perfectly, but to learn something and yeah, show all these findings, but also to make it as affordable as possible for everyone to assemble. And even if it's more expensive, at least that you are able to acquire one of those sensors. And yeah, at least a couple of months ago, BME 280 were like a shortage in Serbia. I don't know why, but probably due to the global electronic components shortage reasons.
Yeah, if I knew that there is such a problem, I could send you a bunch of them. They're quite cheap in Ukraine, like $3 or something.
Yeah, also I forgot to mention the like pricing around to create this complete sensor. I think it's between 55 and 60 euros with all the components, all the sensor wirings and everything. So when I got all the prices from the websites that are available, I think yesterday I was like scraping the prices from the AliExpress, eBay, and some electronic sites.
Yeah, and also I think, right, Milos, in that amount, most of that amount is the Raspberry Pi itself.
Yeah, Raspberry Pi is the most expensive part of it.
Yeah, there are quite some cheaper options that are so less powerful ports, boards with less ports, and so on. We could also went with something that's using less power or has less ports and things like that. But we wanted to try out with something that's like say most popular and maybe most people have already at home, and something that people could like Milos showed, maybe also have a desktop operating system with desktop environment, which is more for someone maybe more user-friendly than SSH or something else. So something that's more powerful, which you can more easily use, and maybe run some Java on it, or I don't know, C# or something like that. So to give more options than something that's really really on low power and low computation power, on less ports and so on. That's the reason why we chose something more powerful and more expensive.
There's actually a way how to decrease the cost, but with some kind of compromise with that. It's Raspberry Pi 0W.
Yeah.
You know what that? It's really tiny.
Yeah.
But yeah, there is no HDMI on board.
And the 40-pin header, I think there is no header on it. You need just to solder everything, each pin to the Raspberry Pi. So yeah, that will be more soldering involved in that case.
Yeah, but you just take soldering fan and you go ahead.
That's true. Yeah, this is like something like solution in between that you try out something, and yeah, as Miro said, you have more options, and yeah, more easier, like it has HDMI, you can connect monitor, and you have that option. At Raspberry Pi even have multiple monitor outputs, so yeah, it's different variations of the Raspberry Pis. Yeah.
But anyway, guys, it was a great solution, really great solution. For the next version, I would recommend you to go with like 2 options, outside and inside. And for the inside, just add a CO2 sensor and maybe a few more gas sensors, which can quite not quite, but dramatically extend functionality, and maybe even to add kind of small monitor, LCD monitor, to present data in-house.
Yeah,
so that would be a V2.
if it catches on, I guess we have more possibilities in front of us that we can use, because pollution and everything becoming more like, I would say that it is awareness of it is increasing, especially in Serbia in the latest years. I'm not sure worldwide how it is, but in Serbia, interest about pollution and everything, it's taking the, I would say, hype.
Yeah, I'm monitoring this thing at home for more than 2 years, and it's really useful, really useful. You know when to open the window to get some fresh air. You can get notification when when air quality outside is going down, and system just informing you to close windows.
Yeah, that's one of the ideas for the hackathon, maybe.
Yeah.
Yes. Are there any more questions? Okay, I guess not. Maybe Miro, if you want, can remind the people to join the other sessions, as I said.
Yeah. So reminder let's do reminder for sessions for this week first. So tomorrow, our colleague Stefan will talk about how we created a custom 3D printed Levi 9 branded case for this sensor. On the image, you can see the prototype, the white one. The final one is in Levi 9 colors, blue and white. So he will not only explain how this one was made, but also show tools that are used for 3D printing, what's the process. He also has, I think, quite nice time-lapse video how it was printed and so on. So you can join that one. Also on Thursday, Vuk, Igor, and myself will present how exactly data from these sensors is sent into the cloud to AWS and Azure, how it's stored, and basically you will see also which data is available for you for the hackathon to use. And then next week we have like more specialized sessions, which will show you which cloud services, data-oriented cloud services you can use on AWS, on Azure, and on Azure also. So it's like to give you ideas what you can use and what you can do on the hackathon itself. So you can see who are the presenters. Next week we have really data specialists talking about data services in the cloud. And yeah, invitations for the meeting, so files that you can import in Outlook and have it in Calendar. You have it in the email that was sent last week, but you also have it on the website. So you can add them to your calendar so they can remind you.
Okay. Well, I guess if there are no more questions, remarks, and everything, maybe we can end this one. Okay, I don't see anybody else unmuting.
Well, thank you very much, guys. Really appreciate it. Thank you for the effort we should
Thanks.
be giving.
Thanks to all, and
Thanks.
see you on the
See you in
hackathon.
the next one.
See you on the hackathon, yeah, the next one.
Yeah.
Thank you. Bye-bye.
Bye.
Thank
Bye.
you. Bye bye.
Thank you. Bye.
Bye.
Thank
Thank
you.
you
Bye.
guys. Bye-bye.
Bye bye.